Hey science learners, how are you all? I hope you all are going great. Today, I, Monishka Khullar, and my friend Vandini Birla are here to discuss in detail various phenomena of light. And do you know what's the most exciting part? That we are going to learn all those phenomena that we might have not noticed in our daily life applications, and we are going to perform them in the form of experiments. But wait, before diving into the world of lightomania, it is very important to understand that what is light. So light, visible light or visible radiation is electromagnetic radiation that can be perceived by the human eye. There are various properties of light such as refraction, reflection, diffraction, interference and polarization, and the very last, that is scattering. Now as you have understood everything about light and its properties, so it's the absolute correct time to understand its phenomena through various experiments, and that too in a very interesting way. Before starting with the experiments, I would like all of you to know that all the materials used in these experiments are easily available at home, and the happy part is we all can try it out. Let's start with experiment number 1. Materials required: a water bottle, a glass, and a pen. Now we are going to start pouring the water into the glass up to the brim. Once it's done, we are going to add a pen into it and observe how does that looks. Not only from the inside but also from the outside, as you can see in the video. Here we can see that the pen looks a bit thicker from the outside than in the inside.
In this experiment, when the pen is placed inside a filled cup of water, it appears bent or displaced at the water's surface. This occurs because light rays bend as they transition from water to the air. The part of the pen under water seems to be at a different position than the part above the water, illustrating diffraction. Diffraction is the bending of light as it passes from one medium to another with a different density, like air to water. This change in speed causes the light to change direction. The degree of the bending of light depends upon the indices of the refraction of the two medium and the angle of incidence.
Let's move ahead with experiment number 2. Materials required: a water bottle, a glass bowl, and any 2 coins. As we have done with the glass, in the same way we are also going to pour the bowl up to the brim with the water. Once it's done, we are going to add first of all 1 coin and check how does that looks. Again, we are not going to only observe from the inside but also from the outside. As you can see at the base of the bowl, the image is a bit different. In the same way, you can add another coin and check. Again, now for both the coins, the image is a bit different at the base, as shown in the video.
The bending of light in this experiment causes the light to change its speed. If the light slows down, it bends towards the normal line, and if it speeds up, it bends away from the normal. This bending effect is described by Snell's law, which relates the angle of incidence and refraction to the indices of refraction of the two mediums.
Now it's time for experiment number 3. Materials required: a glass full of water and any source of light or a torch simply. Now we are going to close the light and project this light over this glass onto a white wall or a white paper. As we can see that the image is becoming very big. Here we have moved the glass from one place to another to observe different images. If you look very closely, there are very fine 7 colors of the rainbow present on the shadow of the hand.
We see rainbows flows due to the refraction, dispersion, and reflection of light in water drops. When light enters a drop, it slows down and bends. Then the light disperses into its constituent colors because different colors bend by different amounts. The light reflects off the inside surface of the drop and refracts again as it enters the drop, further separating the colors. This combination of refraction, dispersion, and reflection creates the circular arc of colors, a rainbow.
I hope that through these experiments, you must have understood these concepts very well. And now you are also going to notice all of these concepts around you and fall in love with lightomania. See you soon. Bye.